It's a limit problem. The limit of sine inverse of x minus sine of x upon x cube as x tends to 0 is 0, 1 upon 3, 1 upon 2 and 1. Now, to solve this problem, the best approach would be L'Hospital's rule. Okay, so let us see whether L'Hospital is applicable first of all. The direct substitution of 0 here, if you see, sine inverse of 0 is 0, sine of 0 is 0, and cube of 0 is 0. So that indeed is an indeterminate form, so we can apply the L'Hospital's rule. Okay, now when we apply the rule, we differentiate the numerator and the denominator separately. We know that derivative of x cube, that would be 3x square. Derivative of sine inverse of x would be what? 1 upon root of 1 minus x square, and derivative of sine x would be cos x. Okay, now let us again see what form we get after substituting x as 0 here. Okay, well, with the denominator being 0, we know that now the numerator should be 0, because in all of the options we don't see anything like infinity or limit doesn't exist, right? And you see that here cos 0 is 1, and this x squared is 0, 1 minus 0 is 1, root 1 is 1, so that's again 0 by 0. Which means we have to apply L'Hospital's rule one more time. Okay, we have to apply L'Hospital's rule again, but well, we can apply it right here, but what I'm recommending you is first you make an adjustment here. Okay, and that adjustment is you can take this 1 upon root 1 minus x squared outside. I'll tell you the reason after we do it. Okay, so if I take this 1 minus x squared outside, not exactly outside but common from the numerator, then we'll get 1 here, and here we will have 1 minus x squared into cos x, right? We'll have 1 minus x squared into cos x. Now, why did we do it? Okay, well, we have product rule here. That's first, if at all we are going to apply the rule again. But now this part has been taken care of. Why? Because if I substitute x equal to 0 right here, I am not getting 0 in the denominator, correct? And I know from algebra of limits, what do I know? That limit as x tends to a f into g, if I want to find, I can find the limits individually as long as I know that the limit of the product exists, right? And so I'll do it here now. So for this part I will put 1, this part I'm going to put 1, and then let us apply the rule. Okay, let us apply the rule. Okay, so what is the derivative of 3x squared now? What is the derivative of 3x squared? It will be 6x. Okay, and let's now go for the derivatives here. Look, well, although we didn't check it for 0 by 0 form, it is indeed 0 by 0, because this is again anyways 1 and this is cos of 0, so that is also 1. Okay, okay, so let's go to the derivative of 1 now. That's 0, right? Now let us apply the product rule here, u dash into v. Now derivative of root is 1 upon 2 root x, right, and into f dash of x, and that would be negative 2x. Okay, into cos x. Now this negative sign that you see here, negative sign, this is outside the bracket. Okay, so by product rule we have a plus sign here. Okay, we'll have a plus sign, but because outside we have a negative sign, let's put negative sign there. Okay, now first function will remain as it is. Okay, first function will remain as it is, and the derivative of second function needs to be computed, that is negative sin x. Okay, negative sin x. So we've got something. Okay, we've got something which now we can take care of. Okay, look, let's cancel 2. Okay, let us cancel this 2. Negative into negative, so we do have a positive term there, positive sign, and we will have x cos x in the numerator and 6x in the denominator, right? Minus Let's keep this root 1 minus x squared as it is. This negative sin x is there, so let's make it positive. Let's make it positive, and then we have our famous limit sin x upon x. Let's not forget that it is actually 6x, but sin x upon x, that limit is 1. Okay, so at the end, what are we getting? X will get cancelled. Cos 0 is 1, so this is 1 upon 6. So that is 1 upon 6 plus this is 1 into 1 upon 6. 1 upon 6 plus 1 upon 6 is how much? 2 by 6 or 1 upon 3. Okay, the answer is 1 upon 3. That is option B. Okay, that is option B. Now, can we solve it on calculator? The answer is, of course we can. Let's do it. Okay. Now, I have been told by students that in NEST, the calculator as you have it for IIT is not there. It is only the basic calculator. Am I right? I mean, the TCS calculator, the big one with all the inverse and sine functions, it's not there for NEST, right? Yeah, they have that smaller version of the calc. But anyways, assuming that it is an IIT question, we can solve it on calci. Okay, x tends to 0, and both inverse trigonometric function and trigonometric function results. I have changed my calculator's mode to radian. Let's take our x value as 0.001. Okay, let's take our x value as 0.001. Let's now see. First of all, I have to take sine inverse of that minus sine of that, and I have to divide it by the cube of the answer. So answer isn't the number that we stored earlier. What did we get? Point and so many threes. So that clearly indicates that our answer is 1 upon 3.